Now let us see that problem. First problem there. Find the sum of odd divisors of 2160. 2160. Whatever the number you take, it must be prime factorized first. So 10 into 216. 5 into 2 into 216 is nothing but 6 into 6 into 6. So how many 2's are there? 3 2's and 1 2. This is 2 power 4. How many 3's are there? It is 3 cube. How many 5's are there? Only 5. This is like this. Now it is prime factorized. What we need? Sum of what? Odd divisors. Avoid the 2 power 4 and apply the formula what just now I have given you. If you want to see the formula again, please go back. If you want to see the formula again, that's what. If you see that, the first one, let us see that. The number of distinct positive integral divisors of where P1 power K1, P2 power K2 and so on, PR power KR or primes in ascending order is K1 plus 1 into K2 plus 1 into so on into KR plus 1. But I have taken them as 2, 3, 5, 7 like that. Here the primes are named as P1, P2, P3. Both are same. Next, coming to the second one, the sum of distinct positive integral divisors of where P1, P2, P3 are primes in ascending order is P1 power K1 plus 1 minus 1 upon P1 minus 1 into P2 power K2 plus 1 minus 1 upon P2 minus 1 and so on like that. So that will give you the total sum of all the divisors. But in this case now we need odd divisors. Avoid this and apply the same formula. So it is 3 power 3 plus 1 minus 1 upon 3 minus 1. It is 5 power 1 plus 1, 5 square minus 1 upon 5 minus 1. So it is nothing but this is 3 power 4, 81 minus 1, 80 upon 2. 81 minus 1, 80 upon 2. 24 by 4, which is nothing but 40 into, it is 6. It should be 240 is the sum of all the odd divisors. Okay, that is application 1. Now we have seen a problem also on this application. What is the application? There are P1 like things of one kind, P2 like things of second kind, P3 like things of third kind and so on like that. Then if you want the number of combinations or the number of selections, then it is the formula is nothing but P1 plus 1 into P2 plus 1 into so on into Pk plus 1. Basing on that only we have derived it. We have derived the number of divisors or the number of factors. Okay. Now, one more thing here. If you want the number of, let me say 10 factorial. Let me say some 32 factorial. Let me say 100 factorial. You know 10 factorial. It is nothing but 10 into 9 into 8 into so on into 3 into 2 into 1. Then if you simplify this, you will get prime factorization for this also. 2 power something you will get, 3 power something you will get, 5 power something you will get and so on you will get like that. That means whenever you take any factorial, that factorial will consist of all the prime factorization. So now, in this case, what we need the exponent of 2. We need the exponent of 3. We need the exponent of 5. In such a case, what should be the formula? The derivation of the formula is not needed. Just understand the n factorial can be written as 2 power, let me say some P1, 3 power P2, 5 power P3 into so on. Okay, if you need exponent of 2, then it should be like this. It should be written like this. N upon 2. This is greatest integer function, step function or greatest integer function. All of you know that. Step of n by 2 plus step of n upon 2 square plus step of n upon 2 cube and so on. This will give you the exponent of 2. Understand, please. An exponent of 3 if you want. Step of n upon 3. Step of n upon 3 square. Step of n upon 3 cube, and so on. Exponent of 5 if you want. Step of n upon 5. Step of n upon 5 square. Step of n upon 5 cube, and so on. This is also an important model. Like, I'll tell you like this now. If you want the exponent of 2 in this expansion, 32 factorial. Example sake I'm taking here. This is 32 factorial is there. 32 factorial, you know, it is 32 into 31 into 30 into so on into 3 into 2 into 1. Okay. In that product, you need the power of 2. The power of 2. It is simply got like this, exponent of 2. In 32 factorial, it is represented like this. Exponent of 2 in 32 factorial. Understand it. Step of 32 by 2 plus step of 32 by 2 square plus step of 32 upon 2 cube plus step of 32 upon 2 power 4 plus step of 32 upon 2 power 5. What is 2 power 5? 32. What will be 2 power 6? 64. More than that. It becomes a proper fraction. Proper fraction means it will be less than 1. Less than 1 means the step value becomes 0. Less than 1 means the step value becomes 0. Step value means greatest integer function. Greatest integer function. You all know that. Now it is 16 plus it is 32 by 4. 32 by 4 is 8. It is 32 by 8. It is 4. It is 32 upon 16. It is 2. 32 upon 32. 1. So 16 plus 8, 24. This is 28. 28 plus 3, 31. 31. The same formula I applied there. So what you understand here now? If you replace n with 32, power of 2 is nothing but 31. Understand? Similarly, you can write the power of 3 also using the same formula, 32 by 3 plus 32 upon 3 square plus 32 upon 3 cube, and so on like that. Then you will get the power of 3. Then similarly by 5, if you write 5 square, 5 cube, so on like that, you will get the power of 5. Okay, so now in this problem, let us take some advanced level problem on this one now. I hope you might have understood the formula to be applied to find out the exponent of 2, exponent of 3, exponent of 5, and so on, exponent of any prime number. Let us go through a problem. Yes. Now, number of ciphers at the end of 2002 C 1001. First of all, don't get confused. Ciphers means zeros. Ciphers means zeros. So you have to find out the number of zeros. How do you get a 0? 2 into 5 is 10. So if you take the product of 2 and 5, then you will get 1 0. Do you understand what I'm saying? If you get, let me say, 2 into 5 gives you 1 0. 2 square into 5 gives 1 0 only, because I'll write separately. 2 square into 5 gives 20, isn't it? 2 cube into 5 gives you 40. 2 power 4 into 5 gives you 8, 16, 5, 80. What does it mean? Even though the power of 2 is increased, the number of zeros are not increasing. But that depends on 5 power only. Understand? If you make it 5 square, then it will be 2 into 5 square is how much? 25 into 2. It will be 50. Okay. Similarly, 2 square into 5 square. It is 2 into 5 whole square. 2 into 5 whole square. That becomes what? 100. Okay, it is 5 square. Let me say 2 cube into 5 square. How much is it? 2 cube into 5 square is 8 into 25. 8 into 25 is nothing but 200. 2 power 4 into 5 square again. 16 into 25. 16 into 25 means 400. It will never exceed, the number of zeros will never exceed the power of 5. Understand, whatever the power of 2 is given, but you have to take the power of 5 only. So the number of zeros depend on the power of 5. The power of 5, even though the power of 2 is higher, it depends on the power of 5. So now in this case, understand, it is nothing but 2002 factorial upon difference is 1001 factorial into 1001 factorial, which is nothing but 2002 factorial upon 1001 factorial whole square. Now I have to count the number of zeros in this one, and I have to count the number of zeros in this one, and then we have to divide to get the number of zeros. So I need the power of 5, because whatever the power of 2 it is, I'm least worried about that. Always 2 will have more power. Just I have shown you. Always among all the prime factors, 2 will have more power. So we are not worried about that. We need the power of 5 here. So exponent of 5 in 2002 factorial. What should it be? That is 2002 upon 5 plus 2002 upon 5 square, 2002 upon 5 cube, 2002 upon 5 power 4 is nothing but 600 plus 2002 upon 600 into 5, it is 125 into 5. It is 625. 625. Again 625 into 5 is how much? 625 into 5. 6 5s or 3000. 3000. That means it exceeds. It exceeds, you understand? It exceeds. You need not have to write that. It exceeds 3000. So it exceeds 2002, that is why you need not have to write. Now what should it be? This is 4, this is 0, this is 0. 0, okay? Because step value, you need not have to take decimal here. Plus, and what should it be? It is 4, it is 8, 0. And what should it be? It is 125, 1, and 75, 752. And it takes 3 point something. So how much is it? It is 19, it is 499. So understand, in this one the power of 5 is 499. Whatever the power of 2, we are not worried. Whatever the power of 3, we are not worried. We take only the power of 5 in this case now. Similarly, you can try for exponent of 5 in 1001 factorial. And of course, you can multiply with 2 because square is there. So in this case, what happens? 1001 upon 5, step off 1000 upon 1001 upon 5, step off 1001 upon 25, step off 1001 upon 125, step off 1001 upon 625. How much is it? 1001 upon 5. It is 200. It is 25. 40. It is 125. 125. 1001 upon 125. And 1001 upon 625 is 1. It is nothing but, it is 2 times. So what should it be now? You count it. This is 240, 249. Because the square is there, you have to multiply this with 2. Because square is there, you have to multiply this with 2. This with 2. With 2 into 2. How much is it? How much is it? 8. 8 plus 1, 9, 4. 498. So the power of 5 in this one is nothing but 5 power 498. And the power of 5 in this one is 5 power 499. And if you substitute that in this one, it is 5 power 499 and it is 5 power 498, means you will get 5 power 1. So you will have only 1 0 in this one, 2002 C1001. You can try that, you repeat that, you repeat it, and you try on your own. The formula given is you have to take the step function. The formula is very much clear to you. If it is n, I repeat the formula for you. It is n upon, that is exponent of any prime number in n factorial is nothing but step of n upon p plus step of n upon p square plus step of n upon p cube, and so on. So what the problem we need is a higher level problem, and we'll be doing such type of problems continuously. Even we can include these problems in the probability also. We will continue this session and keep watching CAP TV. Thank you.